how does change happen? Two ways that change happens, gradually then suddenly. Right? That's Hemingway. Of course, it was in reference to how does bankruptcy happen. And what I'm going to talk about is, of course, this construct affects everybody working in technology, everybody trying to bring about change, which is very central to our careers. And I'm going to talk of this in the context of blockchain, and then specifically within this large blockchain arena that has now become fairly large, specifically about trust and trust technologies, and how blockchain and associated innovation are bringing about trust capabilities. I won't go through the introduction that Jeff has already kindly provided, but I will highlight a few things which are, I feel, a little bit more to the context of this audience, and also listening to Adam's excellent presentation on the work that's happening in the cybersecurity space. Some of the work that we've been doing for automotive, which is being pushed to the edge, that it's not just a vehicle. Autonomous vehicles are becoming computing nodes at the edges, something that IoT experts have to worry about. We've been working with MOBI, the Mobility Open Blockchain Initiative, some work also with Mercedes in Europe, helped run hackathons similar to what the previous speaker was describing in other corporations, as a mechanism for innovation. And this particular work with MOBI, which is a standards nonprofit organization, is in the context of identity for mobile devices. I'm trying not to say automotive because mobility is beyond automotive, since it includes drones and bikes and scooters and so many other things. And it's not just for people, it's for cargo, and it's for delivery, and it's for logistics, of course military applications as well. And many of the trust as well as security issues cannot be tackled unless the identity issue is tackled. It's at the fulcrum. And one of the use cases, the reason I bring this up in the context of a blockchain conversation, is one of the chief use cases for blockchain is around identity, particularly something called sovereign identity. So I'm not going to necessarily talk about identity, but I wanted to highlight some of the work that we're doing in that area with Digital Twin Labs, incidentally was one of the founding members for MOBI. Let me move on to some of the other pieces of my thoughts. There are three patterns that I'm going to take you through. This pattern, and these three patterns really will show you the progression from various dimensions, depending on where your discipline is coming from, and why it is becoming important to attack these areas, to take on these areas around trust, and what is motivating the renaissance in what I'm referring to as trust technologies. Trust was rarely referred to as a technology, but just as mathematical algorithms, which Adam was referring to previously in the context of IoT and security, similarly, human activities are moving into algorithms. I'm not necessarily referring to AI, though of course that is one extreme demonstration of it, but increasingly the use of systems, increasingly the use of mathematics, increasingly moving processes down into algorithms and mathematics is what we are leading towards. So if you look at this pattern, it's more in the context of US markets, but it applies pretty much to all economies and to most economies and markets. But there are a few conglomerates that exist. Most businesses, around the time when I joined the country 30-something years ago, many businesses were still conglomerates. And then when I went to grad school and through my early stage career, companies like Motorola, where I used to work, started focusing on core competencies. This is the era that many of you would remember when re-engineering was at its peak. And then it moved into the dawn of the internet, and value webs started getting established, which is pretty much the status quo today on how prevalent business and transactions are conducted. So most corporations, most transactions are done through value webs. And where we are now is that the complexity of managing the challenges related to trust far exceed the advantages that are available from value webs. What is the new paradigm that we should look to? That new paradigm, which is what me and others in the blockchain space are advancing, is a system or an internet of trust based on decentralized ledger technologies, more commonly called blockchain, though there is a distinct difference between those two. And for those of you who are new to the space, blockchain is one kind of a decentralized ledger technology. I won't speak so much to the right side of that picture, which is more towards autonomous networks, but I will leave this chart by giving an example of what we see the future to be. And I'll put it in the IoT context because there's a lot of interest in IoT in this room. And if you think about the realm of shipping and transportation and logistics, today, you tell the container where it's going to go. In the future, the container will tell you where it's going to go. Meaning, of course, not the destination, but what most efficient routing, loading, unloading it's going to pick. Now, granted, you might have the override and the kill switch against that, but that's the world, just as we are seeing what a world of autonomous driving looks like, right? We have that, right? Some of us drive those vehicles. And the world of autonomous shipping and logistics could look something similar. Now, there are a lot of hurdles to cross before we get to that kind of an end state, but the nature of transactions will change. Just as the nature of transactions and the identity of mobile devices changes, the nature of transaction, and we need a new kind of a transaction system to undertake and secure and track and provide the provenance of those kind of transactions. Which brings me to the second progression, second pattern that all of us have seen a progression, and I'm only putting it in perspective, and that is systems that would tabulate. I worked previously at IBM, which I think when it started was called the, forgetting exactly, the tabulation machine or something else, before it was given the name IBM. And then moved into more, this is quite a quick leap forward between the first and the second icon on that picture, and then moving into systems of automation, all right? And systems of automation were invested, innovated, and put into great scale, particularly in the 90s. That's again around the time when I started my career. And what the re-engineering wave revealed to us is that the weakness is that, yes, you can provide high levels of automation, but if something breaks, it's gone. So it was very brittle. Those systems were very brittle, like ERP systems, for example. And that drove the need for change. That drove the need for putting in systems, developing systems, doing R&D on systems that are agile, that can accommodate change in case of failure, hence anti-fragile, right? The movement that Netflix advanced. Hence agile, iterative kind of methods, right? I'm not referring to fault tolerance because it might harken back to fault tolerant kind of systems, which is different. So the ability to accommodate change became a given. Despite billions of dollars of hardware R&D that went into making servers fault tolerant, there was still failure happening. And the way it was accommodated for, the way it was offset, is by software at higher level layers accommodating for hardware failures, for infrastructure. Let me not say hardware, let me say infrastructure failures. So the need for change, the need for failure, you design given that failure will happen, and now how do you make it almost seamless in terms of recovery for the users? So if your instance of Netflix at the back goes down, you probably don't even notice that it went down. And that leads us to how systems are now being designed, and that is to learn. We were talking about specialized ASICs. I haven't purposefully mentioned over here systems being designed specifically for blockchain. I could argue that case because a large part of the semiconductor industry, I'm forgetting the name of this company I'm trying to think about, which makes the ASICs for mining companies. Some of you might help me recall. Bitmain? Bitmain, thank you, Mark. Good to see you. Bitmain, who incidentally we're going to open up a factory right around here, right outside of DFW. So there is a large part of semiconductor recently growth that has been driven by the demand for large mining data centers, right, specialized. So my point over here is that all the way from silicon up, systems are being built to learn. Let me move to the third rubric, the third pattern over here, and that is the progression from centralized to distributed to decentralized systems. I think everybody understands that. To put it in context, ATMs, and this is not necessarily, I'm not necessarily saying that one wave is entirely supplanting the previous wave, but it adds to the portfolio, particularly when you're dealing with large corporations and you have a portfolio of 50,000, 100,000, 200,000 servers. And that for large corporations, that is the kind of number. In fact, in the world of virtual servers, you're talking about hundreds of thousands of servers, not tens of thousands. So the shift from, so ATMs still exist, which run on mainframes. Airline ticketing still exists, like Sabre, up the highway, which runs on mainframes. And many central agencies do their compute on mainframes. And in combination now, we have had distributed systems, and this is the world which was pioneered by the likes of Sun Microsystems, by the likes of eBay and PayPal and Amazon and so on and so forth. Leading us into what we see as the next wave of transaction systems, and that is decentralized systems. And those are blockchain platforms. All right. The key thing I want to leave with you on this slide are two takeaways which are the most important from my lens, and I think for many others in the blockchain space, on the properties of blockchain that are particularly lending towards trust disruption and making trust a commodity. How do we envision a world where trust, which is otherwise such an important element, becomes a commodity, becomes a utility, just like connectivity is? Right? And these two properties related to distributed ledger technologies are that they are censorship resistant, right? And the second one is that there are consensus protocols which underlies the hum and the plumbing of blockchain-based applications and blockchain-based networks. Now, yes, there are lots of other elements and properties which I'm not elaborating over here that most of you have heard about what blockchain is. It's immutable, it's indelible, it has smart contracts and cryptographic hashes and all that stuff. But if I were to net it out for you, it would be these two elements, which are the bloodline, which are the conscience of blockchain and trust networks. All right. So the reason I call it Renaissance in trust is because trust is not a new element. Trust has existed in different forms, but over ages, for whatever reason, not getting into those, trust gets eroded. It could be the financial crisis of 2008. It could be the Snowden effect and how politics are run. whatever the drivers are. There's an erosion of certain models of trust that have existed, and then newer models of trust have to evolve over the eras. And we are poised at that kind of a situation right now, especially when we look at some of the events over the last, let's say, 1 decade or so. I'm going to look at my screen over here. Some of these bullets are a little bit fine-grained. Can you still hear me at the back?
Yeah.
So consensus I pointed out. So I've basically organized this on how certain innovation is happening pretty much across the stack in order to bring that perfect storm together in having an overall picture of maturity and trust technologies. Consensus, protocols, state, and I'll elaborate on state because that means something specific, and it is something very characteristic of blockchain networks, especially in peer-to-peer environments, which is what blockchain networks are. And you have to maintain state in all those nodes as opposed to a centralized mainframe, which is just one node, and it's much easier to maintain state over there. Cryptography, of course, random number generation, which I was thinking about this part of my slide when Adam was talking, and he was talking, I think, Adam, you were talking about randomness. And this is similarly randomness in blockchain networks on how leader nodes or nodes with certain privileges are elected, right? I'm taking you a little bit out of the proof of work kind of environment for those of you who are familiar with that. And newer protocols are being developed, and if you have interest, you can look up some of the work that is being done by Definity. And randomness in electing and giving privileges to nodes so that consensus can be arrived is a really important characteristic at the infrastructure level for blockchain networks. And that kind of randomness and the underlying consensus protocol is a prerequisite. Consensus protocols are prerequisite in order to provide replicated state to all the nodes. And because there is replicated state to all the nodes, and those nodes could be supply chain nodes or any of those nodes which have multi-party entities, you require them to be at the same state, a single source of truth, in order to trust them. At the application level, programmable contracts, new programming languages, of course, Solidity is well known. There are other languages. Another example is by Digital Asset Holding called DAML, I believe, Digital Asset Markup Language. Autonomous behaviors of applications like what I was referring to in the case of mobility tokenization, so on and so forth. In the integration and interoperability space, atomic swaps, hash time lock contracts, I'm just giving you a few teasers, we won't have time, but I'll be glad to elaborate a little bit more later, so on and so forth. This has more to do with how different blockchain networks would likely interoperate with each other. Most of this work is incidentally happening in payment and currency kind of technologies. But the same work can be borrowed into supply chain technologies. For example, a container shipment ecosystem like the one from IBM and Maersk called TradeLens needs to talk to the food network or Food Trust, which is sponsored by Walmart, because there is a link between them. Maersk probably carries a lot of cargo that Walmart imports from other countries. But those two networks are distinct and separate networks today, right? So there's going to be an importance of joining different ecosystems. I have to tend, right, Jeff?
Yeah.
Okay. So the other aspect of Renaissance, the previous slide was more of a technical leading slide. This is the business, legal dimension, and Mark, keep me honest over here, kind of equivalent of it. Because we want those two disciplines and languages to be bridged. When we are talking about nodes, businesses and the legal discipline talk about counterparties. When we're talking about liquidity in the context of business, the choice of consensus technologies actually does affect and influence the liquidity of a blockchain-based network and blockchain-based marketplace in order to transfer assets. Everything in blockchain networks is characterized and described as digital assets, right? There's a tendency to stop using the word or try to refrain using the word crypto because it's not familiar to a general audience, which is something Jeff and I learned from a conference earlier this week. Valuation, right? So valuation is more of a business finance kind of a term, but valuation from a technical perspective will translate into how I can provide provenance of an asset. If you're in the oil and gas industry, or you're in the aerospace parts industry, and you're trying to sell certain used equipment, which is partially used, how does the buyer arrive at the valuation of that asset? And those assets, some of those parts are pretty expensive. But if you're able to deliver the provenance, hinging on the identity of that item, of that asset, then you can have more trust in the valuation of it. Transferability of assets in marketplaces is really key, and that is also key in order to reduce friction, which is it's related to the liquidity aspect I talked about. Contracts, non-repudiation, which would map to a term that I used earlier, and that is around atomic swaps and time-blocked hashed contracts, right? So there is almost a one-to-one, if not a one-to-one, there is a close mapping between the technology constructs that people like me are looking at. But it's important for people from the technology side to understand what the lawyers have to deal with, what investors have to deal with, what, of course, in all fairness, regulatory agencies have to deal with. I'm drilling down a little bit deeper into integration and interoperability. And the reason I'm drilling deeper into it is because it's always been the breakpoint in systems integration. At the end of the day, this is still systems engineering and systems integration. I mean, and things break, and this is not true just for digital solutions. This is true for mechanical, this lectern or this chair or this table. Things break where there are joints. Things break at integration points. So there are at least 3 motivations for integration. I'm sure there's a more exhaustive list. One is control, logic. The second is logic, and the third is state. The state one is really important because that's what this slide concludes with. Control eventually is about logic. Okay. I want to monitor what we were hearing from Adam. I want to monitor the security and attacks and traffic and all. So I need certain control. But eventually it's about logic. And logic is ultimately about state. How a certain functionality is performed in a state of a workflow over here, and then it's handed over here to another piece of the workflow, and then so on and so forth in any typical business process. You have to maintain state. Think about making an airline booking, right? It's got to know that what your airline is, that you've logged in and that you've selected a seat, and that seat, whether it has a certain pricing associated with that seat assignment. So you're transferring state from one process step to another process step. Within a particular system, and particularly in mainframe, meaning where the physical host is just one, it is easy to maintain state. It's easy to maintain state in a vertical frame, right? But if you go horizontal, which is how systems really scale, and more than that, if you go decentralized, which is blockchain networks, state is a huge challenge. So when you're looking at control, when you're looking at logic, eventually it boils down to that everything comes down to state, which in classic computer science is the context of a finite state machine. So let me throw some more color, since I'm making the argument that state is very important. Establishing state, auditing state, making state immutable, tracking the state, who has custody of the state, because custody is something that is important in many things, or you can think of a supply chain, or you can think about a manufacturing line. State is important in consensus, asset properties, atomic transactions, deterministic behavior, non-preemptive. I mean, you think about it. State provides certainty. You can't get trust without certainty, right? So when we're talking about trust technologies and we were talking about various elements in the stack that are serving to provide this legal and business equivalent functions, right? A lot of it comes back to how state is handled, and handling state, particularly in decentralized environments, is non-trivial. Now, of course, you could ask, why don't we just leave it on mainframes and it's easier to handle state there, right? Or leave it the way, it's a longer discussion, right? And we've seen the progression and the motivations for some of those progressions that I showed you in those three rubrics. All right, tend to forget the clicker is in my hand. Let me just take a look ahead on what I have in the rest of the slides. So I might be able to take a quick minute on this slide. It gets a little bit hairy. But for those of you who are more inclined towards some technology elaboration, I wanted to provide a fair chronology on 5 patterns that I've pretty much worked in all of them through my career for integration and distribution of state. App servers, remember I talked about value webs? Value webs run on app servers, right? So this is your whole lot of Apache, of web servers, of WebSphere from IBM and Oracle. All the tech vendors have something, and of course, a lot of it is from the open source. App servers, in app servers, application and integration logic is not separated. It uses a hub and a spoke kind of an approach. In messaging-oriented middleware, yeah, that's, that goes back, 25-something years now. But the reason I recap this, believe it or not, these are the systems that are in crunch. This is the incumbency that we have to deal with, right? So when we are advising strategy and when we are implementing prototypes, this is what we are up against in supplanting eventually, if not supplanting, at least shrinking that footprint. So messaging-oriented middleware application integration logic is not separated. It uses a distributed integration approach. You might remember the term EAI. You might remember the term ESP, where separates application from integration logic, uses distributed integration pattern. And finally, in that vein, I position distributed ledger technologies or blockchains as in this progression, in this pattern, and it provides a separation of application from logic, from integration logic, and uses peer consensus and integration approaches, right? So the highlighted delta over here, well, it's not highlighted, but the main delta over here is that it uses peer consensus as opposed to distributed or hub and spoke kind of mechanisms in order to arrive at state. When you're dealing with blockchain and trust networks and the future, which is sometimes called the Internet of Trust, just like there is the Internet of Things, you are dealing with nodes, participants, and you're dealing with complex relationships. So a node in a decentralized network is a replicated instance of a ledger, and it typically represents an entity, an enterprise, or a participant in that network. All right? Now, nodes and participants have very complex relationships. They could be complex because of the way business flows work. They could be complex based on what their privileges, what their roles are. They could be complex based on whether they participate in read or write or both kind of operations on that transaction network, on this new transaction system. They could be complex because of privileges they have in how leaders are elected and how consensus is accomplished. All right? And if you up-level that, that translates into how governance is done. So if you think about blockchains are all about ecosystems. They're about multi-parties. And when you're dealing with multi-parties, you have to deal with governance mechanisms. And the governance mechanisms in in puristic blockchain future is going to be algorithmic. Now, some of the blockchain networks that we see today are not using governance mechanisms which are intrinsically instrumented in blockchain technology. They are taking new blockchain technology and applying old governance models to it. Like, I'll go back to the TradeLens example and to the food trust example. The governance model is through your analog joint venture, legal contracts, board of directors, bring the participants in, give them a board seat, shared equity, and those kind of things, not token-based. All right? In peer-to-peer complexity of relationships, the complexity goes up exponentially. The last point is the key takeaway. Distributed state, which is what I was referring to earlier, is really less about state, but it's more about the complex relationship between the parties and the counterparties. All right, so I'm actually going to start wrapping up over here, which is circling back to the way I started, and that is how does change in trust technologies, and this is what I'm referring to as a renaissance in trust, happens. We'll take some Q&A in the time that remains, happen. And it is through two ways, gradually then suddenly. So this is creeping up upon us, and then all of a sudden we'll find that, wow, this thing is here faster than we thought. Those two ways, or those three words, gradually then suddenly, kind of sums up the compound effect of these contributing and component technologies. Those two ways also sums up the complexity of relationships at a legal and governance level, but also the complexity of relationships between nodes at a technical level and how they should algorithmically interact with each other. It sums up the market inefficiencies and market fractions that happen, as well as friction that happens in conducting transactions. We have to view. It would be a folly to view the future world in the context of today's lens. So if we think of autonomous cars, we can't just think of cars the way we drive them today. We have to think of autonomous cars as a car being repurposed in its function, on the fly, to carry passengers on one demand slot, carry cargo on another demand slot, be a ride-hailing device in another slot, in another on-demand slot. I'm trying not to use time slots because it's more based on demand as opposed to, hey, for 2 hours I'm going to do this, and 2 hours I'm going to do this, 2 hours I'm going to do this. These are the challenges that companies like Avis and Hertz are pressed with today because they're losing out big time on business given fewer of us are renting cars. We get out of the airport and what do? Right. So that's what the automotive manufacturers are thinking, that how can we have a car which can, basically, it's the same physical asset, but it wears a different digital skin, which is partly also a little bit of the motivation of Digital Twin Labs, the name of my company. So how can you repurpose physical assets, and it ties into the IoT future, how can we repurpose physical assets with a digital skin on demand? And then of course it's identity and the transactions that serve it running on a blockchain kind of a network. So the approach of gradually then suddenly also sums up how, weeds ruin a garden and termites ruin a home. How exponential technology and disruption happens. And technology and disruption, even though they sound and we use them hand in hand, hand in glove, but the way I would have you think about it is that it's actually hard to explain disruption through technology. The best way to explain disruption is through economics. I'm not a trained economist, though I do have an MBA kind of a background. But I do increasingly, as we as an industry advance the envelope of technology, I do increasingly lean on economic literature and trying to make sense of it. And when you read the works of Ronald Coase, a Nobel laureate from the 1930s, as his original work, when he defined the theory of the firm based on transaction cost, and how transaction costs, reduction of transaction cost, determines the size of a firm, then it makes sense on why the internet happened and why blockchain must happen, right? Why distributed ledgers. When you go study the work of Doug North, sorry, not Doug Thomas, Doug North, he will explain to you, and that's a fairly recent Nobel laureate, he will explain to you how you can organize without organizations. Let me say that again so it sinks in. How you can organize without organizations. That's the economic phrase. And the technology translation of that is decentralization of networks, decentralized networks, where you don't have a centralized node which must censor and clear your transaction. The network arrives at consensus in order to settle those transactions. And that's where we see this new era kind of headed. Thank you.